Hi folks, welcome back to another tutorial video in the Unity series. Today we're going to be taking a look at AI mechanics and all the required components in order to make our enemy model, which we should have implemented from last session, follow the player and provide us a mechanism in which to produce an attack script. Now the first component we're going to be looking at today is the NavMesh agent. The NavMesh agent is going to be the component that allows us to control all the AI mechanics associated with a particular model. And it doesn't just have to be attached to an enemy, it could be attached to an NPC as well that's perhaps patrolling an area, or animals within our scene, etc., whatever you see fit. Now the NavMesh agent can be found within the add component in the inspector. What I'd like to do is left click on your enemy model, go to add component and search for that NavMesh agent. Now once you include it, you can see in your scene view here that it encapsulates the model with a wire cylinder, and this wire cylinder is associated with a set of attributes. Now these attributes include the steering, so the speed in which the model is going to be going or moving. Mine is a zombie in this scene, so perhaps I want to reduce mine down a bit, but you can tinker with it once we get the mechanics up and running. The angular speed is the speed in which it turns. The acceleration is how fast it goes from 0 to 60, for example. So if the enemy model is reaching its destination, the acceleration will force it to slow down at a certain speed. Same as if it's going from one waypoint to another where it's starting, acceleration will determine how fast it starts and goes into a walking mode. So for mine, I'm going to set mine relatively high to around 20 because I want the speed to be kind of consistent. The stopping distance in here as well is also how far away it's going to be stopping from the target that it's intended for. Within my scene, of course, I want my enemy to be following the player when I get within a certain distance. So I want the enemy to stop around maybe 1 unit away, just so it provides a little bit of space between the player and the enemy, but allows such a range that it can still attack. So I'm going to increase my stopping distance to 1. Now the auto braking checkbox here is responsible for slowing down the enemy when it's starting to reach its stopping distance. If we're doing waypoint systems, it's unlikely that we want the auto braking to be checked to true, because if the enemy is transitioning between waypoints, we don't want to see it slow down in real time. Instead, what we want to do, we want it to transition between each waypoint consistently. Because we're only dealing with the enemy AI mechanics in terms of following the player and trying to attack the player, we're going to leave auto braking to true. But certainly when we deal with waypoints, we need to be taking auto braking off. Now we can also see here obstacle avoidance, and the radius is responsible, of course, as to the overall, I guess, width of the NavMesh agent, and it just wants to encapsulate your entire model. So the radius needs to be reduced or increased depending upon the size of your model. Mine's going to go down to around 0.4 just so we can encapsulate the container, or rather the capsule collider sufficiently. The height needs to be adjusted so it encapsulates the total height of your model. So I'm going to reduce mine to around 1.9, so just above the UI element. And we can also see in here quality and priority. Now the quality, of course, determines how well it does its job at detecting obstacles within the scene. If we set it to none, it won't detect obstacles within the scene and it won't try to avoid them. Low quality, similarly, will not provide a sufficient amount of obstacle avoidance and it won't add to that realism. If we use a higher quality obstacle avoidance, it will require higher processing performance. But for now, I'm just going to leave mine to high quality. If it affects your scene too dramatically, then you can reduce that down. Now we also have pathfinding here as well. Auto traverse off mesh links is responsible for ensuring your enemy model transitions between different walkable areas, which we'll get onto in a minute. And auto repath is associated with whether or not the AI will try to repath itself, so rewalk around a certain area if its intended target goes missing, for example. So it's important to keep that to checked so that the AI will be responsible for ensuring its own path is always calculated. And we also have area mask as well, but we're not going to cover this for the time being. Area mask is just covering anything that can be walkable, not walkable, jumpable, etc. So just leave that to everything at the moment. Now, once you've got the NavMesh agent component all set up, we're now going to take a look at how we can tell the AI exactly which areas of our scene are walkable and not walkable. Now, to do that, we need to open up the navigation window. So you can find that within Window at the top of the Unity Inspector and by selecting Navigation. Now, this will open up on the right-hand side, depending upon how you've got your system laid out, but it will open up in a tab next to the Inspector. Now, this navigation is responsible for baking the scene, so baking the walkable area and non-walkable areas, as well as selecting which objects are walkable and not walkable as well. The first tab I'd like you to direct to is the Object tab. Now, if you've got an object within your scene selected, so let's say, for example, the terrain, we can go over into Object and select whether or not it's walkable or not walkable. Now, obviously, we'd like the terrain to be walkable, so we want all the grassy areas, etc., to be walkable. But we want to be able to avoid some elements within the scene as well. So perhaps we want to avoid the barrels, we want to avoid the house, etc. So we need to make sure we go through each object within our scene and either set it to walkable or not walkable. So, for example, the house. So if I left-click the house within my terrain, I want that one to be not walkable. So I've set there not walkable. But the terrain as a whole wants to be set to walkable because we want everything on the terrain, the actual terrain object, to be walkable, but all of its terrain child objects, for example, if you set any child objects, to be non-walkable. So go ahead and left click some of your objects within the scene and set them to walkable or not walkable. Now, if you've got any objects within the scene that are likely to move, using this method is unlikely going to produce effective results. For example, the barrels, which you all have within your scene or should have within your scene, are likely going to be interacted with. So, for example, if they blow up, they're going to be moving. If a player walks into them, they're going to move. And the problem with producing a static navigation for these barrels, it's going to retain its initial position. So even if the barrel moves, the baked walkable area is going to retain the same location. So if, for example, I'll just show you this up close, but if I move this particular barrel this way, the walkable area, or not, rather non-walkable area, will still be retained within its original position. So in fact, what happens when an enemy, for example, walks into this area, it's going to walk straight through the barrel, or try to walk through the barrel, and it's just going to keep moving the barrel. So that's not going to be sufficient. So instead, what we can do, certainly for non-static objects within our scene, is to apply what's known as a NavMesh obstacle. So instead of going under navigation, we can go to the inspector, left click elements within your scene that aren't going to, or rather that are going to be movable. And instead what we can do is add what's known as a NavMesh obstacle. Now this NavMesh obstacle takes a form of traditional colliders, so you can readjust its center, its radius and height, etc., just so it encapsulates the model more effectively. But what we're looking for is the carve checkbox. Now the carve checkbox is going to be the one that's responsible for recarving the non-walkable area within your scene every frame. So even if it moves, if you've got carve checked to true, it's always going to be carving the non-walkable area within the scene. So our enemy, irrespective of where the barrel is, will try to avoid it. Now obviously you can't see this very well at the moment because you don't understand, based upon the scene view, exactly where's walkable and not walkable. So what we have to do next is we have to bake the walkable and non-walkable areas. So once you've got them all set up and you've ensured you've added any nav mesh obstacles to any moving components, or a non-walkable area static option to any static objects within the scene, we can then go to the Baked tab within the navigation window, and we can bake the walkable and non-walkable areas. So once you've done that, you can see that all the blue areas are going to be walkable areas, and all the non-blue areas are going to be non-walkable areas. Now, just to show you what that carve option does, if you left click one of your red barrels or any other barrel within your scene and just move it around, so I'm just going to go back to navigation, just move one of your barrels, you can see there it recarves the barrel every time it moves. So this is going to be the same when it updates within your game as well, and the enemy model will try to avoid it irrespective of where its position is. Now, one of the issues, of course, that you're going to face is if you've gone through your terrain and you've made every object a static navigation. Now, the issue with that, of course, when combined with a NavMesh obstacle, is it will still retain the original static position. So any obstacles within your scene that you want to move, you need to make sure that the navigation within the object tab is not set to navigation static. All right, so that's going to be the same for each barrel in my scene. I'm going to remove the static navigation, and I'm just going to go ahead and go back to bake and rebake that. So you can see when it rebakes it, it now produces a carved only area and doesn't retain its initial position. Now, to further adjust the baked walkable area, we can also go into the baked tab within the navigation window, and we can set max slope and step height. Now, the max slope is responsible for calculating what areas, in terms of angles, the enemy AI is allowed to walk up. The higher the value of a max slope, the higher the angle it can walk up. So, for example, this mountain is seen here. If I increase the max slope all the way up and click bake, you can see some of these areas are now walkable. So the enemy AI could perhaps jump onto this ledge. It all depends upon what you want your enemy to do. Mine's a zombie, so it's unlikely it's going to be able to climb the mountain, so I'm going to reduce mine down to around 30 and rebake the scene. So you can now see some of these areas, or a little bit more of these areas, are now not walkable. Now there's also a step height in there as well. Now step height refers to the maximum height of steps it can actually walk up. So you can see in this example here, I've got a house with steps leading up to the top of the house. And depending upon the height of those steps, I can adjust the step height to stop the enemy model from walking up them. Now this area already is a static area and therefore not walkable, so it's not going to affect my model, but if you've got any stairs within your scene that you want your enemy to actually walk up, you can go ahead and increase the step height or reduce the step height appropriately. Now once you've finished adjusting your baked area, we can now go ahead and start to script some of the mechanics for our enemy. So what I want you to do is open up your enemy controller script up in Visual Studio, and we're going to start to look at some of the components that we need to include. Now, the first thing we're going to want to include within the script is the library of syntax to allow us to interact with the NavMesh agent. So right at the top of your script, we're going to have to include a new using tag, and that's going to be of type UnityEngine.ai. Now, once you've included that, we're then going to have to actually reference the NavMesh agent, because obviously the NavMesh agent is the one that's going to be controlling the enemy AI mechanics. So you've done this before with the rigid body when we got the rigid body component of the bullet to make it move across the scene. So you should know by now that we need to create a new variable for that component. The component variable that we're going to create is a NavMesh agent, and we're going to give it a name. So I'm going to call mine agent. Now, whenever we create a variable for a component, we then have to initialize it within the void start method. So we're going to go ahead and create a new line called agent equal to get component, and the component we want to get is the NavMesh agent component, which is attached to our enemy. Now, once we've added that component, we need to understand exactly what our enemy is going to be doing. In this video, we're going to want the enemy to follow the player when the player gets within a certain distance of it. So we're going to need to include a few variables, one of which is going to be a placeholder variable to allocate the actual target to the enemy, and the second one is going to be the distance that the player has to get within in order for the enemy to actually start walking towards it. So that's going to be like a look radius for the enemy. So to include these variables, we need to go underneath our public class again. The target variable is going to be of a type transform, because obviously when our enemy moves, it's going to be moving towards an X, Y, and Z coordinate in space. So we need to understand exactly what position the target is currently at, i.e. the player. So we're going to do this of type transform, and we're just going to call that target. And while we're up here, we're going to include the look radius as well. So that's likely going to be a float value, and we're just going to call that look radius. And you can make it equal by default to something if you wish, but you can do that also in the inspector, providing of course that you set that to a public variable. But I'm just going to make mine equal to 3F for now, so 3 units of visibility for the enemy. Now within the void start method, we need to make the target equal to our player. We need to do this in the void start so that all enemies within the scene that we have within the game will automatically understand exactly where the player is. That doesn't mean to say, of course, that every enemy will suddenly start moving towards the player, because, of course, we want the player to get within a certain distance of them before they start moving. But to do this, we need to make the target equal to a game object, so the player's game object. But the best way to do it is to find the tag of the player. So you're going to make the target equal to a game object first, but the game object also has a separate function associated with it, which is called find object with tag. So game object find object with tag. So the tag we want to find, of course, is the player, and this is providing, of course, that you've gone into Unity and you've selected your player and given it a tag of player. So this is going to just provide an efficient means in which to always reference the player object without having to drag and drop the player in as a public variable, which of course would be another viable option. However, this player game object now, you can see, irrespective of whether or not I put a semicolon on the end of it, it will be underlined red because the target variable is of type transform. So the problem with that, of course, is it can't convert a game object into a transform type. So right at the end of the line, before the semicolon, we need to do a dot transform. All right, so that's going to get the transform of that game object and push that into the target variable. Now, just so we can go ahead and understand exactly what's going to be happening within our scene in terms of the enemy's look radius and the distance, therefore, in which the player has to get within for the enemy to start following it, we can include what's known as a gizmo. Now, this gizmo will allow us to see the radius that our enemy can see within the scene view when the enemy model is actually selected, but this isn't going to be displayed actually within the game. It's just to give us our bearings. Now we can create this in a new method, and this is going to be a void on draw gizmos selected method. Now the on draw gizmos selected method will allow us to left click the enemy model, and it will produce a gizmo when we've selected it. So this isn't what's going to be displayed actually when the game runs. But within here we can draw a new gizmo, and this gizmo is going to be a draw wire sphere. So we're going to draw a wire sphere around the enemy object to allow us to understand exactly what the look radius is. Now this draw wire sphere function needs a position. So the center position is going to be the transform dot position. So that's the position of the enemy model. And it also needs a radius. Now the radius, of course, we've already set because it's the look radius. So inside this this function here, we can just set the radius to equal look radius. Now once we end that line off with a semicolon and head off back into Unity, you can see there when I left click my enemy model, when it updates, it's now got a wire sphere around it. So if we go on a bird's eye view, we can see there that the enemy, or rather the player, sorry, needs to get within this distance in order for the enemy to start following it. Now we need to code, of course, the actual following script. So we've already got the target in place. So we've got the target is equal to the game object at find object with tag player.transform. We've already got the look radius in place, and now we can see that look radius. We're now going to want to detect whether or not the player has got within a certain distance of that look radius. Now to do this, of course, we need to understand exactly what the distance is between the player and the enemy. And we're always going to be wanting to check it. So it's likely going to be situated within the void update method. And the first thing we're going to want to do, of course, is find the distance between, always find the distance between the enemy and the player. To do this, we're going to create a new float value, and we're going to just call this distance. So we're going to be checking for the distance all the time. But with vectors, so with transforms and vectors, there's a handy little function called dot distance. So we can actually calculate the distance between two objects all the time. And what we're going to do is make distance, the float distance, the variable, equal to a vector3 dot distance. And the distance that we're actually checking for is the transforms dot position and the target's position. Now what this will do is find the distance between the transforms of the enemy and the player, and it will push that distance into a new float value called distance. Now what we can do then is produce an if statement to check whether the distance is less than or equal to the look radius. So inside your void update, we're going to do if distance is less than or equal to look radius, then that is when we're going to make the enemy move. For now though, we can just check to see if this actually works, and we can do that using a debug.log. So the debug.log will of course display a message when this if statement is true within our inspector. So I'm going to go debug.log and I'm going to say player detected and end that line off with a semicolon. So when we go back into Unity now and we click play, whenever our player character gets within a certain look radius, we should see at the bottom left hand corner of the screen player detected. Okay, now we know this works now, so we can go back into Visual Studio and actually do the movement code. Now the NavMesh agent comes with its own function to aid with this endeavor, and it's a simple one line code that sets the destination of the NavMesh agent. Now the agent of course is the variable that we want to refer to, because that's what we initialized it as in the first instance. And we're going to use the agent.setDestination function. Now the setDestination function needs a target, and we already have the target, which of course is named target, and we want to go to the target.position. Okay, so what this line will do is it will force the agent to set its current destination as the target's.position when the if statement to check the distance, whether or not the distance is less than the look radius, is true. Now, obviously, the NavMesh agent will perform in conjunction with the characteristics that you set within your NavMesh agent component in Unity. So your enemy, for example, will now walk as fast as you've set it to. So if I increase my speed now to, let's say, 20, and go back to play, and I get within a certain radius, you can see my enemy will follow my player relatively fast. Okay, so obviously way too fast. So I want to go ahead and just reduce that back down again, back down to 0.5, and you can see that a little clearer. Okay, and you can obviously see that is now stopping within 1 unit distance as well. So this is where, of course, we'd actually implement the attack script. Now, obviously, we don't want the enemy to start attacking the player when the player first enters the enemy's look radius. So we are going to want to script the attack script to only occur when the agent, i.e. the NavMesh agent attached to the enemy, gets within the stopping distance of the enemy. So to do this, we're going to have to check whether the distance between the player and the enemy is less than or equal to the agent's stopping distance, which is whatever you set within the inspector. So mine's set to 1. So let's head back into Visual Studio, and within the if statement to check the distance, we're then going to do another calculation for the distance again. And this is going to be checking whether the distance is less than or equal to the agent.stopping distance. And if that's true, of course, that's when we want to do the attack script. But for now, we'll do a debug.log just to see if it works. And then I'll put in there attacking the player. Now, sometimes this does actually throw an issue because the distance that the vector returns, which is then placed in a value of a float value within the distance variable, it can sometimes not calculate correctly. So what you'll often find is an issue if I click play now and run within the stopping distance of the enemy. What you'll find is it won't actually do anything. So you can see that it's not debugging, it's not producing a log saying attacking the player. So what we can do instead is go back into Visual Studio and just add a margin of error onto there. So if we say agent.stopping distance plus 0.5, for example, click save, head back into Unity, this should work now. Now, one of the main issues surrounding this, of course, is the fact that the model itself has a collider on it. So you can see there it's now attacking the player. So if the NavMesh agent is the same size as a collider, it may have issues in terms of when it actually collides with the player and it's not going to go any further than that, so it can't be less than or equal to unless the nav mesh agent is larger than the collider. So we've got to be wary of that. To fix this, of course, you could do it physically. You could go into the nav mesh agent component and just adjust its radius, or you can just add the variance into Visual Studio. Because we now know this is working, you can now go ahead and implement the actual attack script for the enemy if you wish. This is simply just going to be a reversal of exactly the same way that you cause damage to an enemy. So, i.e. the player causing damage to an enemy. So you're going to have to be using the same techniques. So you're going to have to give the player a player health system. So that's likely going to be in some kind of player controller script that you make. Or a player vitals. I've called mine player vitals. And every time the enemy gets within the stopping distance, it's going to pass damage from the enemy to the player vitals script. Okay. Obviously, you can extend on that as well and implement a screen space overlay in the form of a health system slider. So you can see that health reducing every time the enemy gets within the stopping distance. We're not gonna do that for this video. You can go ahead and try to do that yourself because we have done that in previous videos, and it'll be good for you to try to logic that out before the next session.